Welcome to Vertical with Vidir, a podcast exploring the latest in vertical storage solutions.
Hello everyone, welcome to another episode of Vertical with Vidir, a Vidir Solutions podcast. I'm your host, Daniel Litwin, the voice of B2B. And folks, thanks so much for joining us on another episode of the show. Make sure that as you're listening along, you are heading to storevertical.com. Again, storevertical.com. That's our Vidir website where you can find more information on our solutions and services and other Vidir content. But also make sure that you're subscribing to Vertical with Vidir on Apple Podcasts and Spotify for a full catalog of previous episodes, as well as notifications when we drop new ones. So on today's episode of the podcast, we're getting to know some of Vidir's finest to understand some of our work refining and innovating on vertical lift machines. As market pressures from sustainability initiatives to growing fulfillment demands continue to be added on top of various different industries, VLMs have become a straightforward way to reimagine workfloor space, productivity, and safety, to name a few. So today, we're connecting the dots between today's industry needs, our VLM, and the innovations taken to deliver a vertical lift machine from scratch. For insights, we're introducing you all to our engineering team, Dimitri Caldeira, Director of Engineering, and Brady Palsson, Electrical Technologist, both with Vidir. Dimitri, Brady, great to have you both on. How are y'all doing?
Very well, thank you.
I'm good, thanks, Daniel.
Fantastic. Pleasure getting to chat with both of you. Looking forward to sourcing both of your thoughts on this and really getting a bit of a how it's made on Vidir's VLMs. So let's go ahead and start by better understanding the context for VLMs in today's various industries. Why are commercial end users needing a vertical lift machine today? What needs are most pressing based on what y'all have seen?
So the vertical lift modules are a fantastic solution for vertical storage because they bring the density we need for that application. They also bring the accuracy because you're using servo motors technology. And at the same time is a very elegant machine to have in the middle of your facility, if you're an industrial application or a retailer. So as I said, if you're industrial, this machine is going to boost your operations. If you're a retailer like those big corporations, supermarket chains, etc., especially if programs like pick up online and buy online and pick up on store, those machines are going to really upgrade your operations.
So as manufacturers of vertical lift machines, how have these industry needs posed new challenges or new opportunities in the design and creation of your new hardware? Connect some of those dots for us.
Well, everything nowadays is integrated some way or other. You cannot imagine, we have refrigerators with internet access nowadays. I'm not exactly sure why, but they are available. And if you see a VLM and new technologies like remote access for a better service, so we can actually service our machines remotely if this is required. We also have an inventory control inside of the machine, so very precise information. Real data is available for whatever need we may have. So considering Industry 4.0, which is the new trend, we want to have robotics. We want to have a picking arm automatically selecting components without necessarily a man interfacing that operation. Now the technology is in place. Vidir VLM is definitely fully aligned with the future.
All right, let's get a little more specific now. At Vidir, your team has designed a new VLM for the marketplace. So just for a little context before we get into the actual technical specifics, what are some of the main features of a more traditional vertical lift machine, and where do they succeed in your opinion, and also where do they fall short?
What we've seen and what we're striving towards is a more accurate machine that is easier to set up in the field. I think a large portion of the market takes quite a long time to set these machines up, and we've taken a lot of effort to make these VLMs installable in 3 days or less. And I think as we're learning and as our team is learning, we're getting very close to that goal. So I think that's pretty high-end work, whereas we're not in the middle of somebody's production facility for 1 to 2 weeks at a time, depending on how many of these we're putting in. I think that's pretty big. And I think throughout the industry, we see, everybody's attempt at a VLM has different technologies used, and some of them have advantages and disadvantages. And I think that by jumping into our servo motor application, we've negated a lot of the problems that previous manufacturers have had to engineer around. By increasing our accuracy, we can negate a lot of the needs for very expensive positional encoders, etc., given our scheme. And I don't know too much more about competitors or other VLMs beyond, just general brochure reading. So I don't know how far to take these comments, but
I think you hit the nail, Brady, when you said accuracy. So because Vidir is using servo motor technology, we do have the accuracy you want to have on that machine. And today we're offering a basic machine, but tomorrow we may have a customer that wants to fully integrate with many other robots or other technology, and we'll be there for them. But at the same time, Vidir brings the simplicity of a chain-driven machine. With minimum training, anybody can service and detect any potential problems with chains, and it's a very, very reliable product. I believe what Vidir is doing very well is combining both worlds. So as simple as can be, a machine, and at the same time bring the accuracy when we need that accuracy.
And how did the current landscape of vertical lift machines, basically what y'all just broke down, motivate your team's desires to refresh the VLM concept? What were some of the specific areas that, as you decided to build a VLM from scratch, were most important to you to get right?
What we've seen in other models and from other manufacturers, we see sort of a little bit of overselling in capability, whereas we've seen machines stall, and we've seen machines, not be able to do exactly what the sales brochures have said. Whereas Vidir's is sort of undershooting its ability. We're hiding the fact that we can, not really hiding, but we're saving our big guns. We've got pretty heavy duty capable motors in these things, and we're using a portion of it. So kind of to finish that thought, our machine has no problem lifting 1,200 pounds because it's probably spec'd for closer to 2,000. Right now, we're limited by mechanical and steel on our capability, but as we progress moving forward, we'll have the ability to go into heavy-duty models, heavy-duty hardware, etc. Our promise and our sales and our specifications that we're putting out to our customers are more than met, and I think they're going to be very happy with that moving forward.
In terms of motivation of our team here, there's nothing more exciting than developing a new product for engineers. Definitely VLM was our playland and has been our playland for about 2 years of development on this machine. And we have the ability to touch on technology that we didn't use in a day-to-day here at Vidir in the past. Nowadays is our reality. So we are expanding this technology to older products like carousels, for instance. Carousels for some applications getting very sophisticated, and now I have the ability to do the reverse flow. So from the VLM technology, we're bringing back to basic machines as well and make those machines more technological for specific applications eventually.
All right, let's go ahead and get into those technical specifics then, because this is where y'all can really geek out a bit. So let's jump in. Can you go ahead and break down the main mechanical and electrical differentiators of your vertical lift machines? Feel free to get specific and technical here.
Well, maybe I'll start with the mechanical, Brady. And mechanical, there's nothing really new on that machine. We are using technology that has been in place for many, maybe 100 years. But the way we're combining that technology with electrical and automation, that's what makes it special, right? So now I have many sensors that will provide real data, real-time information about the status of the machine, and many other ones that I'll let Brady explain.
Yeah, and I think that's exactly right, Dimitri. Is what we've done is, mechanical is what it is, and it needs to hold weight, and it needs to be able to move weight. But what we've done with these servo motors is we've sort of reinvented the use of high position motor drive and position sensing. So it's pretty neat. The VLMs, when they ship out, are essentially the same footprint in all cases, but the big piece of variability is the height. So we hope that we can take these machines, anywhere from 15 to 30 feet now, and beyond that, multiple story buildings in the future. And no matter what height we ship out, the base that we've created is the ability to basically have the machine learn itself on a whole and dynamically adjust to the available storage positions. And how we do that is the use of proximity sensors, encoder registration of the values. As the machine learns its bottom limit of travel, we then send the elevator on a vertical ascent. And on 4 corners of the lift, we have laser sensors that are essentially sensing each rail edge as the lift ascends all the way to the top. And as the lift gets to the top, it hits the top proximity limit. So in that very simple motion, we've now learned our entire height of the machine, and we've learned exactly where every rail edge is with relation to the top and the bottom. So it's pretty neat to go beyond that. We're dynamically creating storage positions as each rail edge is sensed. So it's quite heavily automated. And it took a lot of engineering and automation to come up with that scheme to make it simpler for install in the field. So circling all the way back to the machine's ability to learn itself, it doesn't matter the height our customer is asking us to attain. Our machine is capable of doing that no matter whether it's 15 or 40 feet, right? And further to that, the machine itself and its components within it are fully networked on its own isolated network. Beyond that, what that does is allows us to troubleshoot remotely by introducing a VPN cloud appliance. And we work with our customer to have them supply us with a safe internet connection that they've deemed safe on their local internet infrastructure to our device. And through the use of the cloud, we can remotely log into each VLM that we have sold. And we can, as the customer is reporting problems, or we are finding problems ourselves and providing updates, or just general health and maintenance check-ins, we can access those machines all over the world through the interweb safely using a VPN and cloud application.
And I just want to make a correction here on the mechanical challenges, let's put it this way. The technology is old. There is nothing new, a chain-driven machine. But every single step of that development was extremely well calculated. So that machine is made to be reliable. That machine is made to be easily manufactured. That machine is meant to be easily serviceable as well. So you can get inside of the machine and reach every single part of the machine basically very easily. And one eye-opening moment, I was in a different location installing another carousel in our customer, and that customer had bought a VLM from one of our competitors. And that machine took 4 weeks to be installed. When we decided to develop our VLM, we said, guys, this is not what we want to deliver. We don't want to cause disruptions for our customers' operation for 4 weeks in a row, right? So we designed this machine to be assembled in less than a week. And at this point, we are installing a machine in about 4 days. And our goal is to get this to 3 days. So hopefully, that's going to be our next podcast in a few months from now.
How do these technical and mechanical differences affect the engineers who are working on the machines, specifically their workflows, any of their servicing operations, et cetera, et cetera? Any dots to connect there?
We spent a lot of time specifically on sort of feeding off of Dimitri's last comment. We're having these things install in the field faster. So what we did is we had to look at it from that point of view of installation time and efficiency. So what we did was we came back to the drawing board essentially, and we said, how do we trim installation time at the customer? And what we came up with specifically in the electrical side of things is quick connection of all sensors and quick connection of all electrical interconnections. So we have sensors and electrical running throughout this machine that after it leaves Vidir is fully assembled and just has to be put into place and quick connections. So how does that help us in the field? Well, now we don't have the requirement for a fully staffed engineering team to be on site for installation because these items are now quick connect, and they're labeled accordingly, and you can't have crossed wires, and they've been factory acceptance tested here at Vidir for a high level of accuracy, and we're confident sending out our installers to essentially put the square peg to the square hole. So throughout the machine, these quick connect devices, even though they cost a little bit of money up front, allow us to trim that tail end off the installation time huge. Otherwise, we've got 10,000 wires in this thing, and asking somebody to terminate those is quite a daunting task. This way it leaves Vidir complete, tested, and ready for install in the field.
Now, how about on the flip side? How do these mechanical and technical differences affect the end users in their day-to-day use of their vertical lift machine? And if there's any specific industries you can use as reference in your answer, I think that'd be helpful as well.
Well, I would say a good vertical solution machine is the one that the customer don't note that it's on their, don't notice there is in their facility, right? So they want to have a machine that when they press the button, the machine goes wherever they need to go. And in that way, a simple machine with very high accuracy, it's what the customers want. And I hope the word impact doesn't apply here. They are not going to see any relevant need for a deeper contact with Vidir for service or anything like that. But even if this happen, we'll be there for them, and there will be a ability of remote access that machine, so we can diagnostic everything software wise. We can upload new software. We can run that machine remotely if that's what customers allow us to do. And perhaps we can talk a little bit more about future customer needs. Today is a machine that stores parts and bring back those parts for an operator. Tomorrow, they may want to integrate with robots or anything more sophisticated. So, and the technology is in place already. So, as I mentioned before, so it's just a matter of combine that need, the special need, and we can easily customize that machine for the customer.
Are there any other anecdotes that you have based on your time working in the field, working with other clients, where you can point to how you've seen vertical lift machines meet all of these specific industry needs? Any specific customers or impacts that you can point to and reference?
Yeah, I've been in the field doing an install locally here in Manitoba, and there was a point where we did the installation, then we came back to do basically a customer service visit and finalize some product details. And one of the things they found, or were reporting very quickly, is that we filled our machine. So we were concerned about that. So I crawled in there safely, of course, and I looked, and they absolutely had filled their machine. So I was surprised. I said, well, I don't understand. This entire storeroom is kind of still looks the same as to when we installed it. I thought I'd see a lot of the static shelving disappear and the parts on it. And they said, no, you don't understand. We put an entire shed full of parts into this machine in less than a week. So they've cleaned up now a remote location in their yard and brought all those parts that they used to have to go for walks through snowy yards to go and get, now is in the building, warm and at the touch of their fingertips to retrieve. And even later in that day, the general manager of that business came up and essentially had the same reaction that I did. And they said, no, boss, the shed is empty. It's all on this machine. And he went, holy smokes, that's amazing. So I think it was a good accomplishment and a good anecdote for how much these machines can store and how you make something like you want to get parts in Manitoba, Canada, a little more enjoyable than a -40 walk to a tent shed.
That's a good point. We also experienced the same thing with our own internal prototype. The first prototype we made, we start emptying static racks and loading that machine. And that machine we empty all the static racks in a heartbeat, and that machine was maybe 30% full. So it's a lot of hardware and components that can go inside of the machine, and we are not going even to notice that.
All right, just to give y'all a little space to geek out a little bit more on some of the technology work that you've done for your VLMs. Of the specific technical decisions that shaped Vidir's vertical lift machines, which are some of your favorites, or the ones that really get your wheels turning the most, and why?
Well, I like the idea of using servo motors on this kind of application. This is, I don't know if there's any customer or competitor using this technology for this application. We're probably the pioneers on that. And I think it was a solid decision. That machine, that technology give us enough power, or more than enough, and enough feedback as well to be precise where we want to be. So it's really hard to keep using old technology in newer applications going forward, because once we experiment that, you don't want to go back, right?
I think I'd like to mention the fact that essentially the machine is a fully incorporated automated system. We're pretty happy with the hardware we're using in our partnership with Schneider. We've stretched the ability of some of these items to the point where Schneider was impressed with us as far as the limitations that some of their HMI software, experiences, and our programmers locally here have taken their HMI programming beyond what Schneider themselves were expecting us to do. So there's a big shout out to our programmers for setting this machine up to function sort of like a PC-based standard in the industry. The touch and feel of the HMI is very similar to what you might find in iOS or Android usership. Save windows, close windows. It just is very intuitive when you're using it, and we find that our customers and even some of the older store room workers that may be 50 or 60 years old are finding the ease of use here with this product. Further to that, the VLM, I think we should circle back to the use of height detectors and the decision of the VLM dynamically to make safe storage location selections. Every time that a load traverses from the access point into the machine, a light array is measuring the height of the tray contents and then looking into its own database for a safe storage location for this payload. So even though a tray 1, 2, 3 is pulled, it may not ever go back to the same position depending on the orientation of the payload that you put on that tray. So I think that's pretty neat. And I think dynamically to create that, we have to give a pretty big shout out to our automation team for accomplishing this task, and it's definitely worthy of a mention.
All right, Dimitri, Brady, we're just about done with our conversation here for the day. Last main question I've got for you is future focused. So how do you see future vertical lift machine solutions, and therefore your coinciding engineering work, continuing to evolve? And for what reasons? What do you see as the main motivators for evolving VLM solutions?
I think that taking these VLMs into industry in North America, they're going to quickly be recognized for their advantages in a warehouse. And I think that the customers are going to buy one and see the advantage. And then 2, 3, and 4 models might be ordered for the same area in fairly quick order. And I think the networking and this ability for those machines to work together is a very short, immediate need in the future. So we're currently developing that. Moving forward. Beyond that, I think robotic picking or robotic vision sensing picking may quickly come into focus here as we go forward. Not having an actual person standing in front of the machine populating or executing a pick list, I think will be something that we're looking at in the very near future. And if whatever you're picking off that machine can be placed upon a cart that just travels to the person who requires it throughout the warehouse by use of an automated guided vehicle, I think could be interesting in our very short future too.
Very good answer. I would just add the ability to integrate with other systems as well. This is something that is not in our radar, and pretty soon we're going to deliver on that. So if you have a operation that needs to receive feedback of inventory in real time, or you want to select remotely which parts machine needs to deliver, this is going to be in place in the near future as well.
Yeah, I think that's a very good point, Dimitri, and that a lot of larger companies already have an ERP system and they're not interested in, reinventing the wheel every time. So that's one thing I think Vidir does very well is works with the customer's pre-existing components and we integrate into their system rather than trying to reinvent their systems.
And that does it for our conversation today. Thank you so much to both of our guests, Dimitri Caldeira and Brady Palsson. Again, Dimitri is Director of Engineering and Brady is an electrical technologist, both with Vidir. I appreciate both of y'all's insights today on the podcast. It's really been a pleasure so far.
Thank you.
Thanks for having us, Daniel.
And before we sign off, if folks want to find out more about some of the work that Vidir is doing around VLMs, whether that is to source y'all's solution or just to get some more resources on whether or not a VLM is right for their organization, how can they get in touch? How can they learn more?
We're going to have a few people after listening to this Google what a VLM is and what it looks like. So we've got an excellent resource online at our website. And if they have questions beyond that or how a VLM will help them in the future, I think a quick call to our sales or using the contact us buttons on that website will get them in touch with our very high-powered sales staff and they'll be able to technically answer whatever question you'll have to throw at them. And the great part about working for Vidir is sales staff work just down the hallway, so it's very easy for them to pull in engineering and for us to solve any inquiries or special requests that they may encounter very quickly.
All right, everyone. Thanks again for joining us. Always a pleasure. And thank you to everyone listening to today's episode of Vertical with Vidir, a Vidir Solutions podcast. If you like what you heard and want to listen to previous episodes, make sure that you're going to our website, storevertical.com, or subscribing to the podcast on Apple Podcasts and Spotify. I'm your host, Daniel Litwin, the voice of B2B. Till next time.